Hey everyone, welcome back to the channel. So, we are continuing with our DSA with C++ series, and today we are talking about one of the most fundamental data structures, arrays. Arrays are the foundation of like half the DSA problems you'll ever solve. Sorting, searching, two pointers, sliding window, all of that stuff is built on arrays. And for those of you who are absolute beginners, don't worry at all. We are starting from the ground up. Let's get into it. Alright, so what is an array? Think of it like a row of boxes. Each box holds a value, and each box has a number called an index starting from 0. As you can see on the screen, the very first element of an array have index 0, then the second element has index 1, and so on like this. So here we are having an array of 5 numbers. The boxes are numbered as 0, 1, 2, 3, and 4. So this is 0 indexed and it is very important to know. Now let's actually write some code. So first we'll say hash include iostream, then using namespace std, and we'll start with the in main class. We'll start with declaring an array of 5 integers. So for that, first we will write the data type of the elements of the array. So let's take it integer. Then the name of the array, which is ARR. We can take any variable name here. Then inside the square brackets, we are just defining the size of our array. So let's say 5. This is equal to, we'll start with curly braces and inside this we'll write the elements. So let's say 10, 20, 30, 40 and 50 because we had written here 5. So 5 elements. So see how simple that is. I just declared an integer array called ARR with 5 elements and I can access any element using its index inside square brackets. How? Let us see. So first we write cout, that is to print, and then the element to be printed. Let us say ARR with index 0. This square bracket 0 is index 0. And we already saw here that the array and the element with index 0 is 10. So here we should get 10. Now let us print another element also. Let us say with index 4. Let us run this program. So you can see we got 10 and we got 50. 50 was the element having index 4. Now a couple of things to note. First, the size is fixed. Once we declare an array of size 5, it's size 5. You can't add a sixth element later. That's a limitation of static arrays. We'll talk about vectors later in the series. Those are dynamic. Second is that we can declare without initializing. Let's say if we just write this int array 5, this means that all values are garbage undefined behavior if we read them. Or we can also initialize it like this is equal to, and in curly braces we write 0. So this means that all the 5 elements of the array is set to be 0. Now we can also let the compiler figure out the size. So if we say that this is written and we just don't write 5. So it automatically takes it itself to be 5 as we have written 5 elements on the RHS. Okay, now let's talk about how to actually do things with arrays, and for that we need loops. The most common thing we'll do with an array is traverse it, meaning go through every element one by one. The classic way is to use a for loop. So for that, let us first take a variable n. So int n is equal to 5. Inside it, let's start with the for loop. For int I is equal to 0, I is less than n, I plus plus. So we just started with a for loop. Then inside this, we will print every element of the array. So we'll write C out, then ARR, which is the name of our array, and here we need to give the index number. So as we know that I goes from 0 to the last indexed element, so we'll just write I here. And we can say that we need to give a space between all the elements. So I starts at 0 and goes up to n minus 1, which is 4 here. And we print ARRI each time. So you can see we got this 10 space 20 space 30 space 40 and space 50. That is, we got all the elements from 0 to 4 of this array. Now C++ also has a range based for loop, which is super neat for when you just want to read all elements. Let us say we write here x in ARR. So this is just that int x colon ARR. So this just means that for every element in this array, this for loop will run and then it will print the value of that element, then a space, so on like this. We can see the output. So here we should get the same output, and yeah, we got. Now some common array operations like finding the sum of all elements. So for that, we can consider here int sum is equal to 0. This is a variable that we are considering. And now we'll say for int x in ARR, sum plus equal to x. This sum simply means that sum is equal to sum plus x. That every element when it will traverse, it will just be added into sum. That is a variable. And at last we'll print this sum. So we'll do it like this. So here sum should be 150, and yeah, we got it. Now the next one is to find the maximum element. So for that we can take a variable here as max, and here we'll say that it is first equal to the first element or the element with 0 index in the array. Then we'll traverse through the array, and here it will check if x is greater than max, then max will be equal to x. So we'll just change the value of this variable maximum. If we got a an element that is greater than maximum, then the value of maximum should be changed and it should be equal to that element which is greater than it. So let's see. So here we got 50. Now some of you might take maximum equals to 0 initially, but don't start it with 0, because what if all the elements are negative? Then you will get an incorrect answer. Now next thing is to reverse an array in place. So for reversing an array, what we can do is, like if we have this array and we need to reverse it, then here we can say that we can first swapping the first and the last element. So then it will be 50 then 20, 30, 40, and 10. Then if we swap second and second last element, then we get 50, 40, 30, 20, 10. And the middle element will be as it is here if we swap it with itself. So this array, if you see carefully, is a reversed array of this one. So you just have to swap the elements first and the last, then second, second last, so on like this. So for that, let's take two variable, one named as left and another as right. So the left is 0 because we're starting from the 0th index element, and the last one has an index of n, so we'll say here n minus 1, or and we haven't defined here n, so int n is equal to 5 here. Now we'll use the while loop. In while loop we'll say while left is less than right, this loop should go on. Why? Because if you see that when we reversed when we swapped both of these elements and then both of these elements, then we had to stop when we had reached here 30, after 30. So if you carefully see this, it will be left is less than right. When left is less than right, then we need to keep swapping the elements. We can see this if left is 0 and right is 4, then we have to swap. Then left is 1 and right is 3, then again we have to. Then when left and right both are equal to 2, then we have to stop. So that means the condition was true when left was less than right. Inside this, we'll write swap left and right, and then we'll say left plus plus, right minus minus. Oh, I forgot to print the array. So for int x in arr cout x the space. So you can see we got 50, 40, 30, 20, and 10. So this is actually a first taste of the two-pointer technique, and it shows up everywhere in DSA. Keep this pattern in your head. Alright, now let's level up. What if you need a table of data like a grid or a matrix? That's where 2D arrays comes in. Think of a 2D array as an array of arrays. For example, if I write here int matrix 3, 3, this is equal to, and here if I write 1, comma 2, comma 3, then here 4, comma 5, comma 6, 7, comma 8, comma 9, like this. So here I have a 3 cross 3 matrix because there are 3 rows and 3 columns. And this is what I have written here. So first it is the number of rows, and second square bracket contains the number of columns. To access element at row 1 column 2, what we have to do is first we have to see like this is row 0, then this one is row 1. So we want to access row 1 column 2. Let's write here row 1, column 2. So row 1 is this. Then this is column 0, this is column 1, and this is column 2. So you can see we got 6, row 1 and column 2. Let's verify it by printing here C out matrix row 1 column 2 element. So you can see we got here 6. Now you need nested loops, one for rows, one for columns to print it. For that, we'll write here for int I is 0, I is less than rows. Here we'll define the rows as well. So we know number of rows is 3. Then next thing is I plus plus. So we are just incrementing I by 1, starting from 0 till it is less than number of rows. Now this is for rows. What for columns? For that we need another for loop. So for int j is 0, j is less than calls, and then j plus plus. Now I'll simply print here I and j. So ith row and jth column index element. And you have to write here int calls is equal to 3. That is the number of columns. And if you notice it carefully, we'll see all the elements in one single line in the output, like this. So, but we wanted it to be printed in this form. So 4, 5, 6 should be in one, 1, 2, 3 should be in one, like it should be row wise. So for that, outside the inner for loop, we'll write here cout and L. This is for next line. So you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9. We got the result correctly. This is how we printed a 2D matrix. Now let's calculate its transpose. Transpose just means that the rows becomes columns and the columns become rows. So let's say we have a matrix here. Just initializing this matrix. This is int trans we have given to this matrix. This is the transpose matrix that we'll get after transposing matrix. And we just have defined the size because the size remains the same. Now inside this for loop, we do not have to print, so let us just remove this. We just want that our matrix, that is a trans matrix, will be formed. So in this is a property of the transpose matrix that rows becomes columns and columns become rows. So this trans will have j number of rows and I number of columns. And so we are writing this equal to matrix I comma j, like this. So this way we'll get our transpose matrix. We can even print this. And here we'll write cout trans. Oh, we're defining it twice. That's not required. We can take different variables here just so that it does not confuses you. So the N1 will be K, then this will be L, and here we'll say next line. So we have taken this variable so that it's more clear that here we are printing. So the for loop we are using here is different from the for loop we used here. So just the second one is just to print this matrix. So if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, we got it correctly. Do not get it in this form with spaces because we haven't given any space here. So if we would have written it like this, we would have got the correct answer. Now this comes up a lot in competitive programming and coding interviews, remember it. So now let's actually solve problems. First one is linear search. Let us remove this all and here start with linear search. So the question says given an array and a target value, find the index of the target. This means that array is given and a target value is given. And we need to return if the target value is not an element of array. Just have to find at which index that target value is present in the array. So for this, let us make a function linear search. Inside this, we'll first input an array and we'll input a number n because we want the length of the array, and the third will be target, which is already given in the question. Now we need to search a particular element in that array. An array, we know this array is 1D array. So to search, we can just traverse through the array and we can check for each number whether the number is equal to our target value or not. If that is equal, then we'll return that particular index, and if it's not equal to any of the values, then we'll just return -1. So we'll start with the for loop. For int I is equal to 0, I is less than n, I plus plus, and we'll see if that element is equal to target. Then we will return I because we want the index. Otherwise, if it's not equal, then we'll return -1. So we'll write here because then the loop will be exit from here if that target value is not found, and then it will come up here to return -1. So this is the function that we made. Let's just test it here. So first of all, let me remove this from here. Yeah. Now we'll write linear search and we'll give an array. So let's say 10, 20, 30, 40. Then it is of size 4 and target be 20. Oh, it's an initializer list and not an actual array list, actually, writing it this way. So instead of this, we'll first define int array is equal to this, and we just give the address of that array, means the name of that array, ARR. So we stored this value in A and then we can print A. Let us see. So we got 1 as the answer And yeah, indeed, it's correct. So this has a time complexity big O of n in the worst case because we are checking each element, like the for loop runs for n number of times in the worst case, because when I is 0 then it checks whether the element is equal to target element or not. Similarly for I equals to 1 and so on, it checks n times. That's why big O of n is the time complexity. Now moving on with the binary search. So let's make here binary search. Let's say int binary search is the name of a function, and it takes int arr, then int n, int target. So now what basically we have to do in binary search, let's understand here. If we say that we have an array that may be equal to 1, 2, 3, 4, 5, 6, 7, and 8, and our target value is 8, then first we'll iterate through this, and what we'll do is we'll just say that low is just a name of variable which I have taken, which is 0, which will tell us that we are taking the 0th index element, and let us say high to be another variable that we take in this case as 7, because 7 is the index of the last element. Now we'll see if we'll just calculate the mid value. So mid of 0 and 7, what is it? So mid is equal to 0 plus 7 divided by 2, which is actually 3.5, and C++ it's 3 as its integer division. So we got the mid value to be 3. Now what we will do is we'll just check here 0, 1, 2, 3. We got this element as 4 with index 3. Now we'll see if our target value, which was 8, is equal to this 4 or not. So we know it's not equal. Instead, it's greater than 4. So if it's greater than 4, then it must be to the right of 4, because here we have taken a sorted array. We can sort the array in this binary search. So, and then we can check this. So the, our target element is towards the right side of 4. Now we have 4 elements 5, 6, 7, 8 which need to be checked. Now this 5 is with index 4, this 8 is with index 7. So we'll change our mid value. It will be 4 plus 7 divided by 2, which is 5. And 5 is this. Index 5 element is this. So we'll see if 6 is equal to 8 or not. So it's not equal, 8 is still bigger than 6. That means that either 7 or 8, that is last two elements are left, and we need to check between both of them which one is equal to 8. So now we have two index left, 7 and 8. So we'll uh, first check with 7, then 7 is not equal to target value. So we found the target value, which is the leftover number, which is this, the last element. And we can print that last element. So this way we can go to it. Now let us write this code. Let us say first int low is equal to 0 and high is equal to n minus 1. Now we'll iterate over this when low is less than equal to high, and we'll say mid is equal to low plus high divided by 2. Now we'll say if mid is equal to target, then we'll return mid. Else if this middle is less than target, then we'll say low is equal to mid plus 1. Because we want, like, if the number was 4, then between 5, 6, 7, 8 we need to choose. So that's why low become mid plus 1, that it starts from 5. And the last one will be else high is equal to mid minus 1. This will be when our target number is less than that particular element or mid element. And we'll say if the number is not found, then you have to return minus 1. So that is after this loop ends. Now we need to write here, we already have made our array. Now we'll say, and we can even change this only. So we'll just write here binary, because this was the name of our function, and we have to sort a array here. So we'll just write sort arr plus n. Here our n is equal to 4, and this sorting we can include here algorithm. Now if we run this, so we again got the correct answer, which is 1. Now let us see the time complexity. So here it is big of O log n, because we are cutting the search space in half every single step. So it is massively faster. Now the next thing is to find duplicates. So if we have an array of n elements with values 1 to n and we want to find the duplicates, then one approach can be we can sort the array and check the adjacent elements. So let us remove all this and write again. So if we say that we need an array which should have duplicates element like this. Again, I go into 2. Yeah. Now first we can sort this array. So that will be arr and arr plus n, and here we can say that our n is equal to, this is 8 I suppose. So now we have sorted the array. Now we'll see for adjacent elements. If adjacent elements are equal, then that means that particular element is repeated. So we'll just run the for loop, and inside this we'll compare if arr with index I is equal to arr I plus 1 index. That is, if adjacent elements are equal, then we'll simply print the duplicate element, that is error I and end line, because if there are multiple elements, it should be printed in different lines. So you can see we got 2 as well as 22. Both of the elements were repeated. Now this has a time complexity big O of n log n due to sorting. A smarter approach uses a hash set, but we'll cover that when we get to hashing. Just know this problem has a big O n solution. Now comes Kadane's algorithm. So first let's understand what exactly it is. Let's say that we have this array -2, 1 -3, 4 -1, 2, 1 -5, 4, and we need to find the contiguous subarray with the maximum sum. Then what we can do? Basically, what we need to find is like we need to see -2 plus 1, even -2 plus 1 -3, also -2 plus 1 -3, 4, and also -3 comma 4. So every possible subarray that can be formed from this array with the maximum sum. So for that, first we take the element one by one. So let us take the first element, which is -2. Then we'll see the current sum, which is maximum of element comma current sum plus the element. So what this means that we have to take the element and current sum plus the element. So current sum is -2 right now. Okay, so it's -2. Then maximum sum, it is also -2. Now we'll see the next element, which is 1. And we'll see the element is 1 and the current sum plus element, what is it? So current sum is -2 plus 1, which becomes -1. Maximum of 1 and -1 is 1. So we got the current sum as 1 here. Now we'll see maximum. Maximum is what? Maximum is maximum of maximum sum and the current sum. So maximum -2 and 1 is 1. So we got here as 1. Now the next element is -3. Writing here -3. Then current sum will be maximum of -3 and -3 plus 1. So -3 plus 1, which is -2. So out of -3 and -2, maximum is -2. So we got the current sum as -2 now. Now we'll see the maximum sum. It is the maximum between this -2 and 1. So out of both of these, we got 1, the maximum value. So maximum sum will be 1. And so on, it goes like this. At last, we get a final value of maximum sum. Here we got as 6. So this is our final answer. Now let us write this. Maybe we can make another function. So we'll say int max sub array sum. Inside this int array int n. Then we'll take maximum to be equal to the first element of the array, and same with the current sum. Current sum, this is equal to arr index 0. Now we'll say it will iterate over this array, and then the current sum, mm, oh, then the current sum will be equal to maximum among what? The element and current sum plus that element. After that, we'll see. mm, oh, I have written here incorrectly, but it's fine, it's just a variable name. Then maximum sum is equal to maximum of maximum sum and the current sum. And at last, we have to return maximum sum. Now inside main, we can give an array. Let's take this array and here we'll say that int index is equal to maximum subarray sum, and inside this we'll give this array and n. So what is n here? N is equal to 9, and then we'll print this index. So let us see. So we got here the answer 6, and it is the right answer to this question. So this has a time complexity big O of n because you see we have the for loop here and it runs for n number of times. So that's it for this video. If you found this helpful, smash that like button. Drop a comment below if you have any questions or if you want me to cover a specific array problem in the next video. Subscribe if you haven't already because we have got a lot more coming. Until then, keep coding and I'll see you in the next video.